Hey guys, welcome to day one of polynomial review, and so we're just going to deal with adding and subtracting polynomials. So bear with me because I didn't want to reinvent the wheel and do a brand new lesson from scratch, so you'll just, I'm just going to skip around a little bit from last semester's notes. So I take it fairly slow in first semester. Basically, this is just a reminder of what terms you can add together, right? Like terms. So in my completed notes, you'll notice some algebra tiles. Those we have to deal with in Foundations and Precalculus 10, but only the positive ones, so only the yellow ones. And I review that a little bit, so I'm not going to deal with the algebra tiles in this one. So I'm just going to rewrite this a little bit differently so you can see it. So what I want to go back to is just, because I know you can't quite see it all, is how do we add, right? How do we add them? And so I know in grade 9 I always make sure there's some that are horizontal and some that are vertical. And so when we add them, the brackets don't have as much of a significance if there aren't any like terms in there, right? Which there aren't, because in order to add them we need to have the same variable and the same exponent, or same variable, same degree, right? So basically what I'm saying is we can add a squareds with a squareds. And so let's see if I can just sneak that in here. So I'm going to do this. And what I like, because we never used algebra tiles when I was in high school, but this is an, I'm going to say x squared, right? A squared, x, and a 1. You can see there's that visual of why we can't add x squareds with x's, because we don't have an x cubed, right? So if you have 3a squareds and another one, right, this is just integer work. So 2a minus 5a and final answer. And if you look at my completed notes, you'll see underneath here there's some algebra tiles. Don't worry about that. And I've tweaked the assignment so those questions aren't in there. When it comes to subtraction, brackets are important, right? So we always have to follow order of operations. We can't add n's with 4's, right? So I always say to students, well, here's an option. You don't have to do this, but to write it without brackets, okay? So we have to make sure to subtract not only this term, but also this as well, right? And so then we go back to our adding n's with n's and numbers with numbers, and then we're good. So this is my adding page, and so again, and feel free to use your calculator, hopefully, because these aren't meant to be very, very complicated ones, but being able to deal with integers without a calculator just saves you some time, that's all. So remember, numerical coefficient of 1, so 3a squared plus 7a minus 7. 2 plus 1 is 3. And we write them in descending powers of the variable. So that means largest degree first, so a squareds, a's, and then constants. Yeah, in grade 9, the highest degree I can go is 2. So, but in grade 10, that's not, I can do whatever I want. So if there's multiple variables, don't stress on that too much. But if there's just one variable, descending powers of the variable. I got sidetracked here. 1 minus 3 is negative 2, minus 4 is negative 6. Something underneath there, that's better. And then a couple more up here. So I've kind of mixed up the terms a little bit, so we'll deal with the n squareds first. So 2n squared minus n squared. And you can always put the 1 there. You won't see it in my answer key, but that's the numerical coefficient. Negative 4n plus 2n, and minus 4. And last one on this page, negative 2x squared minus 3x minus 11. So I have these ones in here, but I took these ones out of the assignment, so don't worry about those, but I'm going to skip down to this one here, the subtraction. So I have some of these set up horizontally and some of them vertically. So again, we need to make sure that we are subtracting a negative, and subtracting a positive. So you can look at this as in we take negative 1. And it's interesting how students don't have difficulty with it when, let's say, it's a 2. They remember to multiply everything, but for some reason it's mainly when it's just that one negative. So you can rewrite it if you want. Depends on how good you are. I'll write it for this one. definitely not required. So when we subtract a negative, we know that's same as adding. And then we do the same thing we did before, so negative 3y plus 10y minus 3. So that's the only one I'll do that for. If it helps you out, then by all means use it. So subtracting, gotta be careful here. So negative 3n squared minus 1n squared. Sometimes it helps to say it negative 2 minus negative 1. And 4 minus 8 is negative 4, sliding over here. So here we have 2 minus 1. Negative 1 minus negative 3, that gives us a positive 2. And 1 plus 4 is 5. 2a minus a. And negative 4 minus negative 1. And this one I think I just put in there because in first semester we've just finished the rational numbers, so adding and subtracting fractions, which we just recently looked at. However, this one doesn't say anything about showing the step where the fractions change to a common denominator. So, but we need a common denominator, so this one's going to be 3/6 and 4/6. Right, so that's multiplying this one by 3 over 3 and 2 over 2, so 3 minus 4. And, oh, we already have a common denominator there, so 3 minus negative 1. Oh, that one wasn't too bad. There you go. That's it. Multiplying and dividing is next.